Volume of liquids. Liquids do not have definite shape, and therefore they assume the shapes of the containers in which they are put. In order to determine the volume of a liquid, we take a container with a regular shape. That is, the volume can be determined by using a formula. Then we pour the liquid into the container and determine the volume using a formula. For example, the container could be a cuboid. In that case, if the liquid fills the cuboid, then the volume of the liquid inside the cuboid would be given by the formula for finding the volume of a cuboid, which is V equal to length times width times height. If we take a cylinder and we fill it with the liquid, then the volume would be given by volume equal to pi r squared h, which is the volume of a cylinder. We also have other measuring devices in the lab that can be used to determine volume directly. Such apparatus include measuring cylinder, pipettes, pirettes, beakers, among others. Such devices are calibrated with appropriate scales, and when the liquid is poured into them up to given marks, we only read the marks to determine the volume of the liquids inside. When using devices like measuring cylinder, we must also try to avoid errors by ensuring that the eye is in level with the bottom of the meniscus. Volume of an irregularly shaped solid. Volumes of irregular solids are measured using the displacement method. So we apply the displacement method. In this method, we have to take another measuring device like a cylinder, a measuring cylinder, with known or calibrated scale. So if we decide to use measuring cylinder, for example, then we should proceed as follows. Number 1, partly fill a measuring cylinder with water and note the initial volume V1. If we were to determine the volume of a stone, then we tie the stone and gently lower it into the cylinder. And record the new volume. So water will be displaced and we end up with a new volume V2. The volume of the stone will then be given as V equal to the new volume minus the initial volume. So here we note that the volume of water displaced is equivalent to the volume of the stone. We can also use a Eureka can in displacement method to determine the volume of the stone. In this case, we would need a Eureka can, which is a can with a spout on one side. Then, together with a measuring cylinder, we fill the can to the brim with water, lower the stone into the can, and collect the displaced water into the measuring cylinder. The displaced water will be equal to the volume of the displaced water collected in the measuring cylinder would be equal to the volume of the irregularly shaped object.